It would be unrealistic to present evolution along any branch of life as having a single trajectory for which it aims. This is not at all how scientists understand, conceive, or study evolution. Rather, we can think about the contexts in which things succeed and do not succeed, and try to understand which modes of ecological systems or intrinsic biotic functioning are driving evolution. The continents are moving apart. More things are flying, and more plants are making fruit. I want to tell you about plants in this way. Over the history of the Earth, plants have been doing some fascinating things. And a lot of what they've been doing that's so fascinating is altering their options for reproducing. Let's think about plant evolution as a few key phases. Many basal plants do not have what you would look at and call a seed. They have ways of reproducing that include asexual reproduction, just cloning themselves underground or by little pockets of information that they can disperse. And increasingly, plants develop and produce and show to us different ways of sexually reproducing, including making plants that have different, what we can term male and female parts, that can combine and make a genetically new individual. And then that individual in many plants can also asexually reproduce or sexually reproduce. Something very interesting happens during the Mesozoic. First, we find increasing populations of plants that produce a seed, which is mixed genetic material from sexual reproduction, and they protect that seed in a case. So, for example, our evergreen plants are pine trees, things like this. These have pine cones, and those pine cones have produced a little bit of a case around the seed to help protect it. Next, we can think about a completely different revolution in plants, which is flowers and fruits. So flowers are sophisticated sexual reproduction devices that plants use to exchange their genetic information with other individuals. And they often produce fruits, which in wild, naturally occurring plants might be very small, but in the plants that we like to domesticate might be pretty big, and things that we can eat. We can think about one component of this story is the formation of the continents, where we have Europe and Africa today, and North America and South America today. They are continually spreading apart from each other in what we now call the Atlantic Ocean along the mid-Atlantic ridge, which is where those plates are actually separating, and they're spreading farther and farther apart. That has been going on since the Jurassic period. So when these continents were touching, it was Pangea. So we can think about the supercontinent Pangea coming together, and then dinosaurs show up on Pangea. And then ever since dinosaurs have been around, Pangea has been splitting and splitting and splitting, and basically bringing us the continents that we have today. Early in the Mesozoic, we have Triassic animals, which are, dinosaurs are only a small part of Triassic life on land, right? We have many other gigantic, terrifying animals that, to be fair, if you got in a time machine and you say, oh, look at the dinosaurs, they weren't technically dinosaurs, that's okay. Dinosaurs in the Triassic were mostly small and scampering. We've talked a lot about the features of basal dinosaurs. In the Triassic period, we have basal dinosaurs representing at least some of our earliest groups of long-necked dinosaurs, at least some of our earliest groups of meat-eating dinosaurs. I like to think of the Triassic period, the way it's been taught to me, is that this is when dinosaurs shared the Earth. The Jurassic period, you could consider that to be when dinosaurs ruled the Earth. In the Cretaceous period, that's when we can think of our most derived, our most complex, and a lot of our most charismatic and famous dinosaurs, right? We have T-Rex, we have Triceratops. These are the dinosaurs we think about often when we think the time of dinosaurs. These dinosaurs are actually from the Cretaceous period, and in fact, some of these are from the very, very latest Cretaceous period. What we have in the skies during the whole Mesozoic includes lots and lots and lots of flying reptiles that are not dinosaurs. Now, if we think about the evolution of birds, we should keep in our mind that the evolution of birds is part of a dinosaur story that includes theropods that get ridiculously large and theropods that get actually quite small, and theropods that had some minor feathers, some helpful feathers, and theropods that had feathers that become fundamental to their function as an animal.